Hello everybody. Now I'm going to explain chapter force, the first chapter of physics. Objectives of this video are to define gravitation, to list the factors which affect gravitation, to state and apply Newton's law of gravitation, to prove formula F equal to G m1 m2 by d square, to define capital G, and to solve numerical problems based on formula F equal to G m1 m2 by d square. Force. In simple language, force means it is simply push or pull. So when you push an object, then it will start moving, and if the moving object is uh, applied with force from opposite direction, that body will comes in rest. That means force can change the state of body from rest to motion or vice versa. That is why force is an external agent that changes state of body from rest to motion. And since force has direction as well as magnitude, it is a vector quantity, and its SI unit is Newton and CGS unit is dyne. And the relationship between Newton and dyne is 1 Newton equal to 10 to the power 5 dyne. And force can be measured by a device known as spring balance. This is spring balance. Now let's go to geocentric theory. Before 16th century, people used to believe that Earth is the center of the universe, and along with the sun, all the planets, all the satellites revolve around the Earth. This concept is known as geocentric theory. But later on, a new theory was developed known as heliocentric theory, and according to this theory, sun is the center of universe, and around the sun all the planets and satellites revolve around. Gravitation. It is also called force of gravitation or gravitational force. Either the bodies are huge, or it can be two different atoms. The two body, they always attract each other towards its center, and that force which attract two bodies towards their centers is known as gravitation. That's why the force of gravitation is defined as the force of attraction between any two bodies is known as gravitation. Here we have to underline the words any two bodies. The two bodies can be heavenly bodies, or that two bodies can be simply atoms. It depends on masses of two bodies. So if mass of two bodies are big, the force of gravitation also big, and if the mass of two bodies are small, then the force of gravitation also is small. And it also depends on the distance between them. If more distance, then the force of attraction between them will be less, whereas if they have less distance, then force of attraction will be more. That's why the force of gravitation depends on masses of two bodies and distance between their centers. And this is the reason all planets, you can see here, all planets revolve around the sun. What is the reason? Because sun has got really a bigger mass in comparison to total sum of mass of all planets. That is why all the planets revolve around the sun. So it is seen that the total sum of all planets and satellites, that is equivalent to 0.0015 part of sun. That means sun is really a huge heavenly body. And gravitation affects more on liquid than solid. And that is the reason that tides are seen in seas and ocean due to effects of gravitation of moon and sun. Effects of gravitation. So one of the effect of gravitation is that because of the gravitation there is existence of solar system and all the heavenly bodies revolving around the sun. Tides in seas and ocean are due to gravitational force of sun or moon. As I told you before, the gravitational force has got more impact on liquid than solid. That's why the tides in seas and oceans are due to the gravitational force of sun and moon. And around the earth there is atmosphere, and that is also due to the gravitational force of earth. Newton's universal law of gravitation. So as the heading itself says Newton's, that means it was developed by great physicist Sir Isaac Newton in 1687 AD. So it states that the force of gravitation between any two bodies is directly proportional to product of their masses. As I told you, if more mass, more force of gravitation, and less mass, less force of gravitation. That means they have similar relation between force of gravitation and masses of two bodies. And if the relations are similar, that relation is called directly proportional. That means the relationship between force of gravitation and the mass is similar. More mass, more force of gravitation, less mass, less force of gravitation. So such a relation is called directly proportional. Whereas if the distance relation is opposite, if more distance between two bodies, there will be less force of gravitation. And if there is less distance, more force of gravitation, and more distance, there will be less force of gravitation. That means between the force of gravitation and distance, there is opposite relation. And opposite relation means it is inversely proportional to the square of distance between their centers. This law is also known as universal law. The reason is that this law is true for any two bodies, either terrestrial or celestial in universe. Now we have to prove formula F equal to G m1 m2 by d square. So this is the figure. So this is the body whose mass is m1, and this is another body whose mass is m2, and from the center we take the distance, and distance is d, and the force of gravitation that arises from the center of two bodies, and that is F. Suppose there are two bodies of masses m1 m2 separated by distance d, and the force of gravitation between them is F. According to Newton's law of gravitation, we just have learned force of gravitation is directly proportional to product of their masses, and similarly force of gravitation is inversely proportional to the square of distance between them. Now combining 1 and 2, F and F results F, and m1 m2 and 1 is m1 m2, and by and d square. So when you remove the sign of proportion, it comes equal to and constant m1 m2 by d square. So where g represents universal gravitational constant. So in this way we can prove formula F equal to g m1 m2 by d square. When force of gravitation becomes equal to universal gravitational constant. So you can see we just now proved formula F equal to g m1 m2 by d square. So if the mass of both bodies are 1 kg and the distance between them is 1 meter, then if you put those values here, F same, g mass 1 kg, m2 1 kg and distance 1 meter, then F results g. That means when mass of two bodies are 1 kg and distance between them is 1 meter, then F becomes equal to g. That's why when mass of two bodies is 1 kg each, and distance between them is 1 meter, then F becomes equal to G. Sometime question may ask to you, in what condition force of gravitation is equivalent to universal gravitational constant? So your answer is when mass of two bodies are 1 kg each, separated by 1 meter distance. Define G, or define universal gravitational constant. So just before we discuss about it, so when mass of both bodies are 1 kg and distance is 1 meter, then F becomes equivalent to G. So now we are going to define G. So G is force of gravitation. When? When mass of both bodies are 1 kg separated by unit distance, 1 meter distance. So the same language we are going to write. So G is defined as G is defined as force of gravitation between any two bodies of unit mass separated by unit distance, and its value is 6.67 into 10 to the power minus 11 Newton square meter per square kg. Its value was first calculated by scientist Henry Cavendish using sensitive balance. This picture is sensitive balance. It is also known as gravitational constant, as its value is independent to masses of any two bodies, means its value is always same no matter what mass the two bodies have. And similarly, it doesn't care what is the distance between their centers, what is the medium between them, and their shape and size. That is why it is called gravitational constant. Now let's go to numerical problems. So in numerical, the same formula we can slightly modify it into capital M small m by r square. So here r represents radius also, r represents distance also. So when to apply these two formula? If mass of two bodies are similar, here similar means if both masses are small, or if both masses are big values, we can apply this formula. Whereas if mass of one body is huge and other is small, then apply this formula. So here example I want to give you. Question is, if two masses A and B having mass 500 kg and 2000 kg respectively are separated at a distance of 25 meters from their centers, what will be the gravitational force between them? Now here you have to decide which formula to apply. So here both masses are small. There is no big difference between those masses. So means we'll apply the first formula. So solution, mass of body A m1 500 kg, mass of body B m2 equal to 2000 kg, and distance D is given 25 meter. So gravitational force F equal to what? So we have formula F equal to G m1 m2 by D square, or F equal to value of G is 6.67 into 10 to the power minus 11 into m1 is 500, m2 is 2000 by and distance is 25, so that's a 25 square. So if you multiply this upper numbers, it gives 6.67 into 10 to the power minus 5 divided by 25 square means 625. So if you divide this whole, then your result is 1.067 into 10 to the power minus 7 Newton. Hence required gravitational force is 1.067 into 10 to the power minus 7 Newton. Similarly, let's discuss another example. The mass of Earth is 6 into 10 to the power 24 kg and its radius is 6380 km. Calculate the force of gravitation between Earth and a body having mass 1 kg. So here you can see the mass of Earth is really a huge number, whereas mass of body 1 kg. So means mass of one body is very big and mass of another very small. So in this case, you are supposed to apply second formula. So let's go to solution. So mass of Earth capital M, here formula also you can see capital M, 6 times 10 to the power 24 kg, and mass of body small m equal to 1 kg, and radius is 6380 kilometer. So we have to convert it into SI unit. So when you convert it into meter, that means multiply by 1000, then it gives the result 6.3 into 10 to the power 6 meter. So force of gravitation F equal to what? So we'll apply second formula, F equal to capital G, capital M, small m by r square. So F equal to capital G means always value is same, 6.67 into 10 to the power minus 11 into capital M is 6 into 10 to the power 24, small m is 1 by radius value is 6.3 into 10 to the power 6. So it is r square, so we have to do it whole square. So if you multiply upper numbers, then the result is 4 into 10 to the power 13, and down if you make the square of this number, it gives the result 4 into 10 to the power 12. So if we calculate it, it comes 10 Newton. Hence, required force of gravitation is 1.067 into, result is 10 Newton. Numerical problems. There is another sample of numerical. So here no values are given. So let's discuss about it. If mass of two bodies are tripled, keeping the distance between them constant, what change takes place in force of gravitation between them? So here you can see no values are given. Simply what we have done is mass of two bodies are tripled, mass is tripled but distance is same, and when you change the mass, question is asking what will be change in force of gravitation between them. As you know, force of gravitation is directly proportional to mass. So here mass is increasing means of course force of gravitation will also increase, but we need to calculate how many times it will increase. So in such case you have to create two conditions. In first case you write normal formula, that is F equal to g m1 m2 by d square. In second case you follow the equation. So when you change the mass of two bodies, you will not get same force of gravitation. That's why to differentiate, we have now written F dash equal to G is always same. In all case, value of G will be same. And as question is saying that mass of the bodies are tripled. So that's why in place of M1, now we'll write 3M1. In place of M2, we'll write 3M2 by. And here question is saying clearly that distance is constant. So that's why we are writing same d square. So if you calculate it, you have dash equal to 3 times 3 means 9 g m1 m2 by d square. So you have dash equal to 9, and here g m1 m2 by d square means f. So in place of, now we replace this with the f, and this is previous force of gravitation and this is new force of gravitation. That's why if we see this, then the conclusion is that this force of gravitation is increased by 9 times than before. Now let's go to another example. If mass of two bodies are doubled and distance between them is tripled, what change takes place in force of gravitation between them? So here you see the difference than before. Before only mass was changed but distance was constant. But here you can see here mass also changed and distance also changed. So in this case, what will be change in force of gravitation? So as usual, in first case, we write same formula as before, same F equal to G m1 m2 by d square, and in second case we follow the equation. So now let's follow it. F dash equal to G, as question saying mass is doubled, so that's why in place of mn we'll write 2mn, m2 we'll write 2m2, and distance is saying triple, that's why in place of d we'll write 3d and whole square. So let's calculate. F dash equal to 2 and 2 means 4, g m1 m2 by 3d square means 9d square. So F dash equal to 4 and g m1 m2 by d square means F. So that's why it becomes 4 by 9 F. So here 4 by 9 means it is less than 1. So less than 1, if the result comes less than 1, it decreases. And if the result comes more than 1, it says increases. For example, in place of 4 by 9, if it comes 9 by 4, in that case it becomes more than 1. So if it was 9 by 4, we have to write increases. But here you can see 4 by 9. So 4 by 9 means it is less than 1. So if less than 1, we can come to the conclusion that force of gravitation is decreased by 4 by 9 times. So this is how we discuss about different types of numerical problems. Now you got some questions here which you are supposed to solve it. So you solve and take picture of it and send me in Viber, or you can send me in mail by 11 April 2020 by 8 p.m. Thank you so much.